Hello, Algebra 2 students. For those of you learning online for Ms. Bell, you guys are looking at this test. It's the Unit 1B test. The beginning of it looks like the one that's for the students that are in the building, but the rest of it is a little bit different. So for number one, you had $199, but you are spending $3 a day. What algebraic expression models this situation? So you're going to have, that 199 in this equation. And you're going to have that 3 multiplied by the days. And you don't know the days. That's going to be represented by a D. Could be any letter, but here they represent it by a D. And you're spending it, so it's being taken away every day. So let that help you choose your A, B, C, or D. You could pause this and think about these, but I'm going to rip right through this test, so I'm going to keep going. What inequality represents the sentence? The product of a number and 5 is no more than 8. Now it's no more than 8. That means it could equal 8. Can't be more than 8 though, so it's everything less than. Okay, so you got to find where the product of 5 and a number, so it's going to be 5 times a letter 5 next to n. It looks like all of these have 5n. So all of them have that. But you got to find the one that it could equal it, but it's less than it also. For number 3, solving the inequality, and you have some choices here. So you were going to subtract 2 from both sides of this inequality. And you're going to have 5r is greater than or equal to, so 16 minus 2, 14. And then, that 14 divided by 5, what does that end up looking like? Okay? And that r is greater than it, so that r is greater than it. A little clue here, whenever you have the variable on this side of the inequality, this is like an arrow telling you which way to shade the arrow. So, it's going to be going to the right. So it's going to be one of these going to the right. So I just narrowed it down to you for you. It's either, C or B. For number 19, you have to use the distributive property first. So you got to take the 4 times the 4. So you get 16b. And then 4 plus the 2, you have the 4 times the plus 2. 4 times a positive 2 is going to be at 8. Okay, so then, you solve for b, and it's going to be one of these. It's going to be a weird one because you have that 16b here, you have 16b here. You subtract that, and so you're going to have 19 is greater than or equal to 8. So it's going to be a weird answer. I'll just tell you that for number 4. Because think about it, 16 greater than or equal to 8. Okay. Moving on, number 5, combine like terms. What is a simpler form of each expression? What you're going to do is you're going to take that -3, multiply it by the -4, and put a y by it. So -3 times -4 is a positive 12, so you should have 12y. And then you have -3 times the positive 3, distributive property. So that's going to be a -9. So you should have 12y minus 9 plus 7y. Can't forget about this. Combine your like terms. That's as far as you can go with that. So there's your number 5. For number 6, what you're going to do for these values, u, z, x, and y, you're going to just plug in, these numbers for those variables. And so go ahead and rewrite the problem out, plug it into your calculator, and see what you get, okay? Remember to use your order of operations. This is an exponent, so that's going to be first. So that y squared, it's going to be -7 squared. When you do that in your calculator, make sure you have the negative in parentheses and square it, okay? Your answer should be positive in the end. Okay, if you don't use the parentheses, what a lot of calculators do, it just squares the 7 and leaves the negative alone and ends up with -49. It should be 49 there, okay? And then, go ahead and multiply that by this and take your u divided by z, and then you add them up. That's the last thing you do. For number 7, what is the solution of the equation? So take 3 times y, so you have 3y. and then 3 times the negative 5 value, so minus 15. So you should have 3y minus 15 plus 2 equals 5. Go ahead and combine your like terms. And then you'll divide both sides by 3, and you'll get y equals whatever. When you combine like terms and try to isolate the variable on one side, what happens here? Is that going to be a situation that's always, sometimes, or never true? For number 9, solve the compound inequality and graph the solution. So what you want to do is you want to solve for x here. So you're going to subtract 11 from both sides, so you get 3x is greater than or equal to negative 18, and then divide both sides by 3 and get that side. Then this side, you're going to add 2 to both sides, and you get 4x is less than or equal to 20. Divide both sides by the 4 to get x by itself. So this is an and. So you have ands over here, so it's going to be either C or D. It's going to be in between. So already A and B get knocked out because they say or again. I don't know why they would do that. Okay, and number 10, you have ors here. So all of these are ors answers, so that's good. You're going to just isolate the variable, solve for this side, solve for this side. Here you're going to add 10 to both sides. So you're going to have 7x is less than 10. You should have open circles on all of these. Yeah, all of them have open circles anyways. So, you divide both sides by 7, you get x equals 1, you should have there. And then so on one of these, you should have an open circle on 1. So you already know it's going to be either C or D. Okay? Solve for x on this side too. That should help. For number 11, is the inequality sometimes, always, or never true? So go ahead and go through this. Use the distributive property. 2 times 6 is 12x. 2 times negative 3 is a negative 6. Then you have that minus 2x. Combine your like terms. See what happens when you try to get the variable on one side. Would that situation be sometimes, always, or never true? For number 12, you have to set up 2 problems here. You're going to set up x minus 2 would equal 1. And since it's absolute value, the absolute value of negative 1 equals 1 also. So x minus 2 would equal negative 1 too. All right, so go ahead and solve for x here, solve for x here. And so you have which answer, A, B, C, or D, matches yours. This one, be careful, because no absolute value should ever equal a negative number. So there's a huge hint for number 13 as you're looking at your answers. Okay. Number 14, solve the inequality, graph the solution. So what you're going to do is you're going to set up 2 different problems, remember. So 2x plus 4, just the way it looks, greater than or equal to 28. And you're going to set up another problem, 2x plus 4 is less than or equal to negative 28. Go ahead and solve for x on each. So, you're subtracting 4 from both sides, divide it by 2, figure out what x equals, and then figure out, A, B, C, or D fits your answer. You're going to do the same thing for number 15. You're going to set up 2 problems. 2x plus 7 is less than or equal to 13, just the way it looks without the absolute value bars. Then you're going to have 2x plus 7 is greater than or equal to negative 13. Okay? And then solve for x on both of those. And I think that's it. All right.